We are finishing up section 6.4 and doing the second half, and we are factoring the sum and difference of two cubes. For this lesson, we are using a shortcut. I'm not a fan of shortcuts. We don't normally use them in Algebra 2, but for factoring sum and difference of cubes at this level, we are using the shortcut, and it's called the SOAP method. The acronym SOAP helps us set our signs. So it sets the signs for our factoring, and so I want to review what SOAP stands for. It stands for using the same sign, then the opposite sign, and the last sign is always positive. So it's a quick acronym to help you remember how to set signs. So a sum of two cubes is exactly what it is saying it is. It is a to the third plus b to the third. It is a sum, addition of two cubic numbers. Your cubic numbers can be referenced by making a quick list or looking at the reference sheet that I gave you earlier in the year. But 2 to the third is 8. That's all we're looking for, cubic numbers. 3 to the third is 27. 4 to the third is 64. 5 to the third is 125. 6 to the third is 216. 7 to the third is 343. And you can go on by typing other things into the calculator. How do I know if a number is cubic? Using this calculator and several like this, we go in and we take a cube root a little differently. So when you look at your calculator, you have x squared and you have your square root key. You might have a different type of calculator, but you'll still have x squared and your square root key. You also have an any power key and you have an any root key. So when I go to take the cube root of a number, I actually have to program the calculator and say, I want to take the cube root. So I type in the 3, I hit my second function, and then I hit my root key. It should look like 3 and then x root of my number. Some of the calculators, when you type this in, the 3 and the x root, it puts the 3 up in there for you nicely. There are other calculators that have a key that says math, and if you go into there, there is actually a cube root option. So once I do that, I see that I get 2. I have to define my root. If I type in 3 and I type the square root key, I'm really taking 3 times the square root of 8. It has to show 3x root of 8. So let's try that one more time. Let's take the cube root of 27. So define your root as 3. Second function, your any root key, it should say x root, and we'll take the cube root of 27, which gives us 3. A cube root is simply what times itself 3 times gives me 27. 3 times 3 is 9, times 3 again is 27. So if you're unsure if something is a cube root, type it in your calculator. The cube root of 343 is indeed 7. So I can always check if it's a cube root. I will get a whole number answer or a negative answer. So my answer can be an integer because I can take the cube root of positives or negatives. All right, so coming back to this, I'm going to look and know that it's cubic by seeing a cubic power or a cubic number with it. And then I'm going to set this up. We are using a shortcut here. There is a method of factoring sum and difference of cubes. But again, at this level, we're using our shortcut and we're using our acronym SOAP and our rules. So what we do is we have a binomial and a trinomial. We set our signs up. So same sign would be a positive sign. That's what I have. The opposite would be a negative sign. And the last sign is always positive. What I'm going to do now is I'm going to take the cube root of my two terms. I'm going to put them in here. So you take the cube root of a the third, which is a, the cube root of b the third. What times itself? So these are the cube roots. All right, now I'm going to build it up. How do I get my first term? I'm going to take a times a squared. So a times a squared gives me back a to the third. Then I'm going to come in and take b, the last term, times the last term, times b squared, and that gives me my b to the third. So we can see that the first gives me back the first, and the last gives me back the last. And then the shortcut really comes into play that the middle term comes from the product of the roots. Again, the middle term is the product of the roots, which is simply AB. So the middle term is the product of the roots. All right, so let me show you this again with the difference of two cubes. We are going to come in with a to the third minus b to the third. I'm going to have a binomial times a trinomial. And since this is a difference of cubes, I start with the same sign, which would be a minus sign. Next is opposite, and the last sign is always positive. So I'm going to take the cube root of my terms and drop them in here, and then everything else is based off of the root. The cube root of a to the third is a, the cube root of b to the third is b. I take my first term times my first term of a squared to come back. So take this and square it. My last term squared is b squared. B times b squared gives me my b to the third. There's my negative sign. And the middle term comes from the product. Now, because we're using a shortcut, this is the one time you can ignore that sign. We just smash the a and b together to make a product of AB. Now, if you look at this trinomial, it looks like it should factor. That a squared looks like it should factor, but we're going to find for what we are doing, this does not factor down further. It is going to stay. So let's go ahead and look at a couple examples to make sense of this. First thing I need to do, like always, is take out a GCF so I know what I'm dealing with. So if I look at 5x to the fourth plus 40x, I have a GCF of 5x. What's left is x to the third plus 8. So a couple things should be happening right now. I should recognize that I see a power of 3. I should see there's two terms. That should be what tips me off that this is a special type of factoring. I have a sum of cubic numbers. X to the third and 8. They're both cubic. So I'm going to come in, I'm going to keep my GCF as always, and I'm going to prep my factoring. So I have my binomial, my trinomial. I keep the same sign, then the opposite and always positive. So same, opposite, always positive. I take the cube root of my first term and I drop it here. I take the cube root of 8 and I drop it here. To build this back up, I base everything on my root. I'm going to take the first term and square it. X times x squared gives me x to the third. 2 times 4, the last times last gives me back my 8. So again, take the roots, then take your roots and square them. The middle term comes from the product of the roots, which would be x times 2 or 2x. This is my final factored form. This looks like a quadratic trinomial that should factor, but there are no factors of 4 that add up to -2. So what we're going to find is when we see this trinomial, it will not continue to factor because this middle term is not doubled. So this is my answer. All right, so let's keep practicing here. Having this shortcut makes this easier, but you need to remember the method. So if I look at B, I see that there is no GCF. Okay. What should tip me off that there's only two terms? And at first I thought difference is squares, but I looked at the numbers. There's a d to the third, that's cubic. 125 is 5 to the third, and 8 is 2 to the third. So this is a difference of cubes. So no GCF, we're going to come in, leave some extra room for your numbers, and we're going to build this. So same sign, opposite, and the last sign is always positive. We are going to take the cube root of 125. Now, if you're not sure what that is, again, we would just enter that in the calculator, define your root. So the third root of 125, and we get 5. So the cube root of 125 is 5. The cube root of d to the third is d. The cube root of 8 is 2. Once I get there, I now need to build this back up. And one of the mistakes is people write this as 5d squared. It should be 25d squared. You are taking this first term and squaring it. So 5 times 25 gives you back 125, d times d squared. Take the 2 and square it, we get out a 4. So Roots drop here, take the roots and square them. Here's one part, here's two parts, that comes back to our 3. And the middle term is found by taking the product. Now we ignore that sign and we take 5d times 2, and we have a middle term of 10d. Again, if you look at this, it looks like you have perfect squares, but the factors will not. All right, in our next example, again, we want to look at this. We want to see that there is a GCF of 2x to the second. I am then left with x to the third minus 8. So if we actually look at this, we can see that x to the third minus 8 is a lot like our x to the third plus 8. So we're going to keep our 2x squared out here, and then we are going to factor our difference of cubes. Same sign, opposite, always positive. All right, so the cube root of x to the third is x. Cube root of 8 is 2. Take this and square it. Take this and square it. And then the middle term comes from the product of 2x. So again, this is a shortcut that I'm teaching. So we do have to memorize the pattern, the trick to do it. This is my final answer. Again, factors of 4 will not add up to 2. Then if you look at the next one, you do have a couple options. This is out of order, so maybe you want to put it in standard form. Now, when I look at z to the 6, it could be cubic or it could be a square. And so because the 8 determines it's cubic, I'm going to use SOAP. But here's where we want to be careful. Same sign, opposite, always positive. The cube root of z to the 6 is z squared. And a lot of people want to make it z to the third. But I need something times itself 3 times. Z times z times z is z to the third. But z squared, z squared, z squared. That is my z to the 6. I take the cube root of 8, I drop it. Z squared becomes z to the 4th when I square it. 2 becomes 4. And my middle term is 2 times z squared. Now that we've finished this last example, I just want to take a minute and show you we're using a shortcut to factor cubics, the sum and difference of cubes. But I do want to take a minute and show you that it does work. So if I take my sum of cubes and I take the factored form a plus b times a squared minus ab plus b squared. So this is the factored form of a sum of 2 cubes. If I take that and I use my distribution method to multiply my polynomials, I would get a times a squared to get a to the third. A times negative ab would be a negative a squared b. And then a times b squared would be a positive ab squared. I would then come back and take b times all 3 terms, so I'd get a positive a squared b. I would get a negative ab squared, and last I'd get b times b to the second, which would be a positive b to the third. And what you're going to see here is I get a negative a squared b and a positive a squared b, and those are both going to cancel. I then get an ab squared and a negative ab squared, and those are going to cancel, and I am indeed left with a to the third plus b to the third, which was my original problem. So I want to show you that yes, our shortcut works, but remember, what I'm teaching you is a shortcut. I am not teaching you the long way to find the difference in sum of cubes. So again, if we have a sum of cubes, we set our signs with a binomial, same sign, and a trinomial, opposite, always positive. Take the cube roots and drop them into your binomial. Take your cube roots and build them back up by squaring them. So your first times your first gives you a to the third. Take your last times your squared, and last times last gives b to the third. And then the middle again comes from the product of the roots. And that is the shortcut for factoring a difference or sum of cubes.